All right, so this is question 617. So here we're given two binary trees and we want to merge them. So in this case, we're given tree 1 here and tree 2. And so what we're going to do is, as we're traversing this tree, we're going to be adding the values together. So 1 and 2 become 3. When we get to this node, 3 plus 1 become 4. And then when we get to 5, 5 plus nothing is then 5. So we're actually, in this case, because this is null, we want to return the other node. And so we're not adding them together, we're just simply returning that node, and so forth. So to do this, what we're going to do is we're going to use the first tree and return it at the very end. And so as we're adding and traversing this tree, we're simply adding the values to tree 1 and then adding the nodes from root 2 or from tree 2 to the tree 1. And so the first thing we want to check is whether or not root 1 is null, and if so, we just want to return root 2. And so that's because, well, for the simplest case, if root 1 is entirely null, so this is just, there is no tree, then we just want to return the second tree. And then the other thing is, as we're traversing this tree, say at 2 here, we then go right. Well, this is null, so we just want to return tree 2's leaf node there, which would be 7. And so we're returning that 7 here. And that what's also nice is, well, this also handles the case where, and I'll set this, actually no, I'll just explain it here, where I'm trying to find the case, yeah, here, if at 2, when they both go left, they're both null, and so it returns null, and then so just return root 2 here, but then that also returns null. So it kind of handles the case of, well, if they're both null, then just return null. So we also want to handle that, but for root 2, and we want to return root 1 in this case. Okay, so next what we want to do is then actually add the values together. So root 1 is itself plus root 2. Oh, sorry, we want the values of them added up. And so that handles when we're just traversing this array, we're adding the nodes. So 1 plus 2 is 3, 3 plus 1 is 4, etc. And so next, what we want to do is traverse this tree in pre-order traversal. And so we take root 1 and we set it equal to our method, and we're just recursing on ourselves. And we just set root 1 is now going to be the left node, and root 2 will now be its left node. So directly after that, we want to do the exact same thing, but with just the right. Oh, so this will be root 1 dot left and root 1 right. And so when we call these methods, it then goes back and reevaluates itself. It calls this method and just kind of recurses on it. And then it also does the same thing for the right. And so finally, we just want to return root 1, which is now all the values have been modified. We're now pointing to the top of the node, and we've added all of the values from root 2 to our root 1 tree, or our tree 1. So let's go ahead and run that and submit it. And success. So it's 0 milliseconds faster than 100%. And that's just because there's only like a couple speed categories here. I think there's only a few ways people solve the question. So yeah, so I hope that helped, and good luck with the rest of your algorithms. Thank you.